Yeah, let's get started. Okay, first, welcome everyone. Also, good afternoon. So I'm here just to share with everyone about civil engineering, civil and environmental engineering. I also invite two of my PhD students, who both are female students, to share their career experience, why they pick engineering as their career, and also about their research like a topic area they are working on. So maybe I will just start with a brief overview, hopefully it's brief overview about civil and environmental engineering, since this is a field maybe you might not be familiar with. And then Xijing and Zhou and Xijing both are here, will then share with you about their experience. Please feel free to raise up any question that you may have during the process. Okay, thanks. Now let me share my screen. So this is a brief presentation I put together. Just give first maybe start with an overview about what civil and environmental engineering is about, and I will briefly introduce about my own research activities, and with Zhou and Xijing chime in to share some of their experience. So, civil and environmental engineering is a very broad area that's very related to communities. So essentially it is one of the engineering disciplines that focus on providing engineering solutions for the needs of society or for the communities. So the basis for preparation of civil and environmental engineers are mathematics, physics, chemistry, biology, and business. These are all what students typically learn during the middle school, high school stage. And then the scope of work, like engineers, they design all kinds of infrastructure that may include like a drinking water supply system, sewer system, national highway system, like high-rise buildings, bridges, solid waste management system, and other type of infrastructure like tunneling, like railway, all these kinds of infrastructure. So this one just give a brief like overview about the typical creation by civil engineers. Like we have all the city, all the infrastructure are part of design construction by civil engineers, like bridges, highway system, clean water supply system. That is all civil and environmental engineering. And within civil engineering, civil and environmental engineering have different areas like concentrations under the umbrella. So that structure engineering deal with design of structures that may be a bridge or a building, and then environmental engineering deal with air quality, water quality, soil contamination, treatment, all these kinds of environmental issue. And then the construction management is about coordination construction activities to make sure like the project is finished within time, within budget. Now geotechnical engineering deal with underground construction, that may be tunneling, earth stem construction, road, all this part of geotechnical engineering. And engineering mechanics this is essentially use mechanics analysis to analyze all kinds of structures. Like that, pre-architecture engineering essentially is prepare engineers to integrate engineering skill sets with architectural imagination. So architectural design, for urban planning or transportation system planning. And also that's like transportation engineering. It deal with design highway system, transportation system, traffic signal, all these kinds of things. And then there's some emerging areas like integration of data science into civil environmental engineering, and also civil infrastructure system engineering. It's a deal with how to achieve global optimization and a lot of constraints, how to choose the best decision. So these are just some kind of a non-exhaustive list of civil engineering areas. In terms of the engineer education, for like we essentially, maybe the goal would be like we all needed to have good fundamentals and also develop creativity and be social aware, like community aware, and understand what they need to come up with a good design, and also leadership skill and professional skill, like interactions, communications, is all very important part for civil engineers to succeed in the career pathway. So in general, like civil engineers is responsible for the design, construction, maintenance of infrastructure. So every day is very relevant to every daily life. Like all these things we interact can be part of the infrastructure. So And then we also face common challenges as our communities or society face. So for example, the climate change with more and more extreme weathers, and also there's urbanization, population growth, and then there's a demand for like a green way for life. So they all put some new challenges and opportunity for civil engineers. So some of like a National Academy of Engineering define the ground engineering challenges. Like these are completely listed here. And then like a few of them are very relevant to civil engineers, like restoration and improve of our urban infrastructure, provide access to clean water, and develop carbon sequestration. So these are all relevant to civil engineering. And then this one is a recent survey by National American Society of Civil Engineers, ASCE, about water, like water cloud from a lot of survey response. So we can see like a civil engineering, what we are concerned with, for example, community or governance structure, or concerned about people, education, internet, infrastructure, culture, job creation, energy. So these are a lot of terms related to civil engineering. And then this one is I observed from a recent project by National ASC about a future ASC future world vision. So what our future world will look like. So this is give like a timeline. So maybe that's the when you become more mature, you might be charged to deal with all kinds of challenges or opportunities with our future communities. This is a time thread. And then there's a lot of community issues that engineers ask for engineers come up with good solutions. And from impact wise, there's a discussion about mega city, rural cities, floating cities. And then there's a lot of technical areas supporting civil engineers to help address these kind of challenges. So I just briefly go through, this is an architectural design, for example, for a mega city that accommodate needs by different people. So this is inside a green space integrated with a structure that make the community more livable and meet the community needs by the citizens. And also there's a lot of smart components that will be integrated into civil engineering systems that provide, for example, for the trash can, smart trash can, will send a message about when it is about to fill up, so that save the energy, save the effort to process the trash distribution. And also the highway system, road system might become power station. They charge the battery for the electric vehicles. There's also a lot of smart infrastructure components will be built in to support community life in a mega city scale. Because rural area also become more sustainable. So instead, it's an architecture design for the future rural city, how they will look like, the infrastructure wise, because rural area provide a lot of support for food, all these kind of essential support. So we want them to be more resilient to disasters, so that the productivity of agriculture for them are not affected by the adverse climate, so like a drought or something. So essentially, there's a lot of opportunities to develop rural areas that are resilient to climate and provide a lot of produce support for urbanization, for urban communities, and for people a community reside close to the ocean or Great Lakes, associated with climate foreseeable for climate change, maybe a lot of opportunities for them to develop these more disaster resilient communities like floating city vision. So the city essentially are floating on the water, and then in the same time they also have a lot of opportunities provided by the ocean and for this kind of environment, this kind of condition. So some of the floating city concept had already been demonstrated in European countries like Italy, Venice, these kind of areas. Considerably, well, this kind of concept were just emerging that impact how our communities, particularly offshore community, interact with the ocean. And also for the community in the cold region, like this called a frozen city. So how to support activities of people in it, like mobility in its frozen environment, very cold climate environment. There's a lot of for example, space exploration, the lunar exploration, Mars exploration. Maybe foreseeable future, civil engineers will be charged to build a new community that's livable, like to support the future like space exploration. So these are just some of the like architecture design, how the civil infrastructure look like in the off-planet areas. In the daily life, our life is also shaped by a lot of new ideas. How do we manage waste? How do we optimize our structural design to achieve the best performance for ventilation as well as such structural support? And how do we deal with the green space, and also how we harvest energies? So essentially, there's a lot of progress from civil and environmental engineering that aims to provide a better life experience for everyone, every residents of the communities. So essentially, for the future civil and environmental engineers, we essentially are good with solving problems that facing our communities. For the future engineers also become predictors for our communities. So we anticipate what may appear and be prepared. So that had been discussed by National ASC as a skill set for the future civil engineers or environmental engineers should bear in mind for their knowledge accumulation. Towards this kind of goal, like a civil and environmental engineering case, we have been building a lot of infrastructure support to enrich our students' research education experience. So this is a large-scale structured lab. So from the photo, we can see the scale is pretty big. So it has a strong floor and a strong wall, allowed to test very large-scale structure. So this is actually the actual component from a historical bridge in the national park that was brought inside the lab, allowed full-scale testing to be conducted. This is some like a panel view of some large-scale testing. Essentially, look at seismic resilience of like a storage house. Essentially, there's if they are stable during the earthquake shaking. And then this one is about pipeline system. So have these 4 shaking tables that emulate earthquake, and then it has a pipeline rise up and then emulate, for example, in a nuclear power plant. If there's an earthquake, if the pipe will be safe. So our structural engineering professors and students work on this kind of large-scale testing with these facilities available at our department. And then, like this facility also allow to test multi-span bridges. For example, in California, in New York, they are subjected to earthquake potential damage by earthquake. So these are multiple shaking tables that generate seismic excitation, and we can evaluate if the structure will be safe under different conditions. Beside that, also our department also had the centrifuge. Essentially, it's a very unique facility that allows to use a small-scale setup to study the behavior of a very large structure. For example, with the centrifuge, we can generate the acceleration 100 times the gravity. In that, with the scaling law, the structure can be scaled up by 100 times. So, which means if we build a structure with 1 meter, that will represent the behavioral structure 100 meters, 100 times larger. So this is a very unique testing facility available at the civil engineering department case. And also the department also built a new geotechnical engineering teaching laboratory. So students have the opportunity to work in groups to finish many different assignments that look at evaluated soil engineering behaviors of soil and rock and geomaterials. This is the same lab, but for the research component. So students can be involved in research activities, working with professor and graduate student to test geomaterials. And also we have like a department support to build this what's called a highly technology enhanced classroom that allows student interaction with faculty professors very closely during the classroom setting. So everything is mobile, allowed to arrange in small group discussions. And also like the study area is very popular. Students usually utilize like space, both for learning and for team activities, discussions. And the most recent development at our department is the new facility for concrete lab. So essentially, it will be allow students to participate, like training, and also participate in research to study the behavior of concrete. The lab is anticipated will be construction will be finished like by the end of this month. But most part is already done. So that's the overview for civil engineering. And for maybe for myself, so I have pretty interdisciplinary training with the training in civil engineering and also in computer science, electrical engineering, computer science. So my research is kind of very in the interdisciplinary domain. I joined the case in 2003, so it had been a long time since I start to work at the case. And enjoyed work with a lot of undergraduate students and also graduate students. So in the research area, as my research is quite interdisciplinary, so it's kind of hard to capture in a short presentation. So essentially, this is one with two of the examples, and then we can then follow up with the two of my PhD students who can share their research activities. So one of the research my group evaluate is what's called a multi-physics process in geomaterials. So geomaterials is or porous materials. It's a material with void space. So for example, we say that soil that we deal with every day, and concrete, cement is part of a geomaterial. Like gas hydrates is energy material, is part of geomaterial. And then we have broadened the concepts as a porous material, then a biomaterial, ceramic, rocks. All these are part of porous materials. So essentially, my group study the multi-physics process in all kinds of porous materials. The examples would be, for example, frost effect on materials, like freezing can damage materials, can cause a lot of issues. For example, the recent news in Texas, like ground freezing cause water pipe fracture. So some of the community will lose water supply because they have an issue, and also they cause a lot of issues for durability of concrete structure. So a lot of bridges are built with concrete, and it's freezing can actually generate damages to the concrete structure, and then they have to be designed properly in order to be endurance to the freezing thawing cycles. And also there's a lot of a natural hazard, a landslide, debris flow, avalanche. It's all part of influence of the either geology or climate condition on the geomaterials. So like in the study aspect, this is just one example for example, for natural gas, for gas hydrate evaporation, we analyze if this is we extract natural gas from gas hydrate under the ocean, how the ocean floor will settle because of the energy extraction. So this is one example. Actually, it's a long story behind, a lot of efforts behind, but then this one just show with the exploration of this kind of energy, how the seafloor will subsidize and involve very complex model process. And then this one is about another area of my group research is about intelligent infrastructure. So we try to make the infrastructure to be resilient and smart. So because for example, one of the issues we address with this concept is about bridge skull. So essentially, it's a bridge failure during the flood. So this is just one example, bridge failure during New York that was captured by the video. So essentially, the stream wash out all the soils, sediments around the bridge foundation, make them unstable. So the bridge cannot support its load, and it will collapse. And then this actually turns out to be a very complex issue, and it requires a lot of scientific evaluation. So essentially, my group have been working on this one to understand why the soils be taken away, because they are detached away from individual particles. and we use like sensing, like very innovative sensing strategies to help provide a warning, just so make it like a bridge user to be safe. So that's some of our research in this domain. So maybe that's my brief overview. We can start maybe question answer part. If you have any question, please feel free to like type in the chat, and me and also Zoe and Xijing can help to answer whatever question you might have. How do you project out? What's the future will look like? Okay. So essentially, I think there's a question about how do you project out what the future will look like. So actually, that's exactly what's the purpose of the ASCE. Share my screen. So this is what exactly like what called ASCE future world vision try to deliver. This one. So essentially, this is a time axis. We are in a stage close to here, and they will envision maybe in the next 50 years or so what the world will look like. And then there's a lot of key supporting area technologies that they say will come up. For example, like in a recent time span, like how the things will change our community life, like flexible batteries, like essentially that can enable a lot of things. And then like drone, use of drone for construction to deliver like material to areas that that may be very dangerous for human being to access. And there's a lot of like for instance, desalination when people explore the ocean, how to utilize the water. Autonomous vehicles, for example, it's coming up right now, but projection is maybe in the 2030, they maybe become like routinely used in the daily life by regular like everyone essentially. So essentially, that's like urbanization, like ASC invasion, that will lead to a lot of buildings that not only provide like residential areas, but also provide green space that interacts with people, improve the quality of life, improve the efficiency and the connections. So that's some of the ideas, like how the future of the world will look like. Yeah, what? Oh, sorry. Let's see. Oh, this is by National ASCE. So I have I have a few questions here. So there's a question, what is the civil and environmental engineering? The same thing, are they different? Yeah, actually, how to say, because civil and environmental engineering both serve the communities. But historically, civil engineering, like environmental engineering is part of the civil engineering. But they have now become slightly different emphasis. Regular civil engineering, we typically focus on like using maybe more like mechanical, like design. So for like a structural analysis, for using like a soil or rocking construction, or environmental engineering. So civil engineering, the basis is more like a physics, like a mechanics, this kind of supporting area. And the environmental engineering is more based on biology, chemistry to deal with environmental issues. So the skill sets a little bit different, but at a case, all the civil and environmental engineering students take same core set of courses, which means they will have the same training as a basic supporting area in all the supporting areas. At a junior, senior level, they have slightly different sequence. Hope this answers your question. And then you have two of these, and then who comes up with those projections? So that's another question. So this projection is by National ASCE, American Society of Civil Engineers. So they were thinking about how our future civil and environmental engineers, what's the knowledge skill they need to have and what they need to be prepared for. So that's the vision they try to lay down based on a lot of interview or like a lot of like study like with people from like both academia and also from like industry about what's the future trend. Okay, so like with as I mentioned, I have student Zoe like give a brief introduction about her research, but unfortunately she cannot speak right now. So maybe like this the PowerPoint she put together. Maybe I can quickly run just representing her. So for Zoe's research is about smart buildings. So we know we like as a regular person, mostly like typically spend more than like 90% of the time indoor. So which means like building is very relevant to the quality of life, how the experience inside the building. So joint research look into supporting areas for smart buildings. So instead of provide input safety, make it comfortable and sustainable, like a healthy indoor environment. So this is overall her goal of the research. So essentially, her dissertation focused on quite a few different areas that all lead to similar goal for the indoor environment. So one of the projects she worked on was a smart material for indoor air quality control. So essentially, using this smart material automatically input the indoor air quality. So and then the other one essentially study with the coronavirus. She's also looking into how we can mitigate the maybe potential danger because of aerosol inside the indoor environment. And also she also shared some of her PhD experience. So essentially, because we spend so much time indoor, like 80%, 90% for some, so essentially the indoor air quality is a big issue, but the indoor environment has a lot of possibility to have like a volatile gas inside, and it can from carpet, from furniture, from the older utensils, they can cause like issues on people's health and feeling. So her research looked at the traditionally we deal with this one with ventilation. So it changed air quality, like exchange air, but then that compromise energy use and compromise air, essentially require energy use and also just a compromise energy efficiency. So for her research, it looked like into how we use the decoration material inside of the building to improve air quality. So instead that's her goal. So instead you have this photocatalytic material. It's automatically moving for some photocatalytic material into the building materials so that they purify the air automatically by the with ambient light. So this is for the photocatalyst. So the material is activated by the light energy. And then she do a lot of work, her research into using the light energy to purify the air using based on the photocatalyst. And the other one, she's concerned, the study is concerned about how to mitigate the danger because of aerosol, because they can carry the virus. And she ran simulations to understand the flow field. And then that can potentially lead to how to effectively capture the aerosol to improve the indoor environment. So this is just some of her simulations. So if people sneezing, like the droplet, the aerosol, how water trajectory they will pass in the room, how they are affected by the ventilation. So this one does not have a ventilation. This is similar like a roof ventilation. Without the roof ventilation, water trajectory will be affected. And then based on that, there's room for refined ventilation design to mitigate latent risk, to improve the health environment indoor. So this is some nothing. She tried to share her, like for example, her career pathway, the decision point for her to pursue engineering career, particularly in her case, pursue a PhD degree. So, but again, sorry, just because the setup issue, she cannot speak out by herself. And then I think Xijing also put together something, but we might not have time to go over. So Xijing works on what self-healing materials. So if you have a damage to a material, construction material, there's a crack in concrete, how we can self-heal the concrete crack. So her research look into biology system, using biology system to automatically heal the cracks to make the infrastructure to be more durable. Okay. Yeah, that's my overview. So are there any other questions? Okay. If not, maybe, yeah, hope everyone, yeah, enjoy the rest of the day. Sorry for the technical glitch. And please feel free to reach out if you have any questions. I can maybe put my contact information there. So if in case you have any question, please feel free to reach out.